Okay, we can go ahead and get started. So welcome, my name is Kevin Saraceno. I'm a member of AmeriCorps. I'm currently serving with Chagrin River Watershed Partners, and this is a presentation called Watershed-Friendly Stream Maintenance for Communities, which is going to be presented by Jared Bartley from Cuyahoga Soil and Water Conservation District. So before we get started, we are going to keep everyone muted throughout the presentation just to reduce any potential interruptions. If you have any questions, you should see a question panel. You can click on that and a chat box should show up. Type any questions you have in there. We will answer them as best we can. We are also going to be recording this presentation, just so everyone's aware. We're going to post it to our website, CRWP.org, as soon as we can after the presentation. And we'll go ahead and get started. So Chagrin River Watershed Partners co-leads the Central Lake Erie Basin Collaborative, which is a network of Northern Ohio watershed organizations and initiatives that work together to achieve healthy Lake Erie watersheds. CRWP received an Ohio Environmental Protection Agency Section 319 grant on behalf of the collaborative, which supports regional technical services to collaborative watershed organizations in addition to our member communities. Happy to offer this watershed-friendly stream maintenance for communities training in partnership with Cuyahoga Soil and Water Conservation District, which is one of our Central Lake Erie Basin collaborative partners. This training is geared for municipal, public works, engineering, township, and county service departments and will provide prescriptive guidance for conducting common stream maintenance activities in a watershed-friendly manner, as well as legal and permit considerations. So with that, we could go ahead and get right into it. Let me turn it over to Jared and enjoy.
All right, thanks, Kevin. Like Kevin said, my name is Jared Bartley. I'm a senior program manager for our watershed and education programs at Cuyahoga Soil and Water Conservation District. Going to give this presentation. This is based on a guide we developed a few years ago. You can see on the image there on the screen. This is downstream of immediately downstream of a culvert at a road crossing. Obviously, a pretty small, not flowing too much channel there, except when you get a good rain, and then got a lot of sediment debris there left at the end. Mission of the Cuyahoga Soil and Water Conservation District is to implement programs and practices that protect and restore healthy soil and water resources. Obviously, we focus primarily all our work in Cuyahoga County, but through our watershed programs and partnerships, including with the Central Lake Erie Basin Collaborative, we do some work and technical assistance outside of the county on behalf of our partners. And just kind of reiterate what Kevin said before, this presentation is being given as part of a Section 319 grant from Ohio Environmental Protection Agency and US EPA. And this should not be considered to reflect the views of either of those agencies. So what spurred this was probably about 5 or 6 years ago. So my work with the Soil and Water Conservation District is focused primarily in the Rocky River watershed, and going around doing some field work, and came across this situation here where a community in the watershed had done some field work, tried to do some stream maintenance to clear out, probably improve flow along the stream channel. And this is not really what we want to see, kind of the barren moonscape. In a previous position when I worked in Western Maryland, we called this kind of thing recreational bulldozing, where you just kind of get in and try to straighten out and clear out the channel. And it wasn't the first time I'd seen something like this, but it kind of spawned like the idea like, hey, maybe we need to do something. And just for reference, this is what that stream channel, so that was at a bridge, upstream of the bridge, this is what it looks like. So kind of forested, nice, relatively healthy looking stream, nice riffle there, wooded. So kind of got me thinking like, hey, maybe there's a better way we can do this. So wanting to kind of put together something, we applied for and were awarded a grant from the Ohio Environmental Education Fund to put together a watershed-friendly stream maintenance manual, which you can see here. It's available on our website, but also it's in the one of the documents available for your download here, handouts in the handouts section here on the webinar today. So the other handout there, so I might as well talk about that now. So we have the maintenance manual as a PDF as a handout. I also have a number of these still available as hard copies if you want 1 or 50 of them for you and your all your close friends to peruse. I'm happy to send some out to you. The printing estimate changed between when we got the grant and when we actually got them printed, so we were able to print a lot more than we originally anticipated. I'm sure some of my coworkers would appreciate getting them out of the office. So just wanted to go on to this next slide. So as we're putting this together, we did some survey work. So we're focusing mostly in the Rocky River watershed this time, but just wanted to see what kinds of issues. Now, we had a pretty good sense of this. We get a lot of calls from communities, from residents, from property owners as part of our role at the Soil and Water Conservation District about a number of stream related issues, but just want to put out a survey, what kind of issues, that communities would self-identify as issues, kind of stream maintenance issues that they would have. As you can see, probably if you're involved with this kind of thing, this should be not be a surprise to you that well over 60% of the respondents, 70% of the respondents said they experienced all of these issues. Streambank erosion is probably what we get called out for the most to take a look at. Obviously, there's everything from culvert and channel blockages due to sediment and debris, channels kind of overgrown with vegetation, which in most situations we consider a good thing, but can cause issues, and we understand that. So at this point, I want to stop and just do a couple quick polls here before we move on to some other survey results. So the first one we're going to launch here is which of these best describes your organization or your employer, like where you work. So this gives us a sense too, like when I'm going through this, kind of who I'm talking to, and can tailor this a little bit as we go. So I'm gonna leave this up for a little bit. And we're up to, give it another like 5 seconds here, let some people vote. We got most people voted, but all right. I'll still got some votes coming in here. Another few seconds. So I'm gonna go ahead and close the poll and then share the poll results. So as you can see, we had about a plurality of people, we'll say, represent a city, village, or township, about 36%, followed closely by county government or other agencies. So over half the attendees really work with a local government of some kind, about 20% private companies, and then some other nonprofit and state and federal organizations as well. So glad to have everyone here. Before we move on, I'm going to head on to our next poll. If I can select here, I'm going to hide the results there. All right, we go on to our next poll. So does your community agency have a program in place to perform regular stream channel inspection maintenance activities? So see how people come out here and see how this compares to the results when we polled people in the Rocky River watershed, probably back in 2014, 2015. So we got these rolling in still. All right, and the NA category, that's, if you don't really work for a community that would have that kind of, picture like a state agency or certain, private consultants or contractors, things like that. So give it another couple seconds here. It looks like we got most people voted. All right, gonna go ahead and close it and share the results. So kind of split here, about 29% yes, a third no, 21% don't know, and 16% it does not apply. So I always like the I don't know. Thank you for being honest on that. Most people, if you don't know, the answer is probably no, but or you might just not work in that department. So one final poll here before we move on. And really this, if you don't have a stream maintenance program, this might not apply. You can say NA, but so, and that should be, when I launch this, that should be when, typo, not we, but when addressing stream maintenance issues, does your community follow a prescriptive protocol? So, let people vote for that. Votes are coming faster now. People are used to the polling activity here. All right. Give another couple seconds here. And looks like, yeah, I got most people voting about to where we were on the other ones. So close this poll and share those results out. So 20% yes, 24% no, another third I don't know, and 23% it doesn't really apply. So either you don't have a program or you don't work for a community or in a situation where you have a program. So I find that's very common. This is not, these are not unexpected results, especially among people who would be interested in this kind of program. Now, one thing, all right, just gonna close that up. One thing I just want to point out, also if you are in Northeast Ohio, Cuyahoga County, and some of the neighboring communities a little bit, if you're in the service area of the Northeast Ohio Regional Sewer District, they may be handling these stream maintenance issues for you in some capacity as part of their stormwater program, but they won't necessarily handle everything in the communities. A lot of the headwater streams are still the responsibility of those communities. So moving right along. So we asked these similar questions, this, I said, this is a 2014, 2015 to engineer service directors in the Rocky River watershed. And you can see their answers here. A little over half said they do have a program in place to perform stream channel inspection and maintenance activities. At least they all knew. I think that was good since I was talking to service department people. And then do they follow a prescriptive protocol? This was roughly a little over 20% did. Most of them, the vast majority did not. And so that really kind of got us into, we asked a lot of other questions with some of these. So you can see just how we were with some of these other results. What's your approach to stream maintenance or complaints on private property? So that's what kind of a lot of the issue is. A lot of these issues occur on private property, and that can be tricky for communities to handle. So about 2/3 said it was a property owner responsibility. I like that. I think that this would be everybody here, make everybody happy. None said it was the community responsibility. Other situations though, it's rarely is it just black and white, cut and dry situation. So, a lot of them, the community would address it if there was a threat to public infrastructure like sewer lines or roads, things like that. The community might address it if they have some sort of easement in that area for infrastructure or for maybe a drainage easement, something like that. Others, community provides advice only. Some they would address it if it's a threat to private infrastructure or other. But the problem is if you don't have this as a part of a prescriptive program, something that's in place and everybody knows what it is, you get to the issues where you have people calling with complaints, they want city to do something. Oh, and maybe this mayor says to do something over here, but then somebody else wants you to fix their issue too. And how do you handle those kind of things? So it's really when you have a prescriptive program in place, you can avoid kind of those conflicts related to unequal application of the program or of assistance. So this might sound familiar to some people. This is an actual email. Town, street names, etc. Names have been changed to protect the innocent and or guilty, depending on how you want to look at it. So this is a email from a councilman. Like I said, this is actually a actual email, basically from a resident with issues. Wants to know if the service director can stop by and check it out, or if the councilman just advise any potential issues or remedies. So this is a councilman emailing a number of people, but including the service director. And so then Service director reply. We cleaned out that stream channel 2 summers ago. I was accused of dredging out the stream and in violation of our own ordinances about the riparian corridor by one of their own employees. The law department said I am duty bound to protect our structures, so that wasn't necessarily the case. There's a petition along Hickory, signed by dozens of the citizens, the residents, who don't want it cleaned out as they like the naturalized green area. But if my basement was flooding, I'd sure want it cleaned out. Parks aren't used to mow these areas, but now they don't close enough to the stream channel anymore, and so it just has turned into a mucky mess. Even the area I cleaned out has been neglected by the mowers. I'm loath to do anything to upset masses of people in order to service a few. It's a political question that needs some guidance. So this is what happens when you don't have an actual program in place. So I call that the stream maintenance status quo, aka the squeaky wheel gets the grease model. So there's no defined program for stream channel inspection or maintenance. So you're basically left to, if you're not doing regular inspections, you're left relying on citizen complaints or maybe observations from your employees when they're out in the field. Maybe there's a regular inspection schedule for infrastructure like bridges and culverts, but you might not be necessarily inspecting it. The primary reason might not be to look for blockages. It's probably more for structural kind of integrity issues. It's largely driven by citizen complaints, and maintenance activities are piecemeal because of that. There's not a program to say like, oh, hey, well, this year we're going to address issues on this stretch of stream behind this road. It's just kind of as they come in, and so they're not really connected together. So it's really not as efficient as it could be. And finally, watershed health and stream quality are really not considered when we're looking at this. And that's kind of what, as I mentioned, what drove this originally is really trying to find a way, like how can we provide some of these maintenance services as communities, but doing it in a way that's still healthy and taking into consideration, the health of the stream channel, watershed, and the watershed as a whole. So there's some examples of these kind of things. We get these woody debris, blockages, log jams, down trees, collecting more debris. It's like silt fence that managed to wash into the stream channel there, got hung up, and it's catching more debris. Get erosion, you get people, homeowners, or cities too, communities, like, oh, the way I'm going to solve this is dumping a bunch of concrete or riprap down there. Those usually don't last too long, especially if they're just dumped on the bank. And they also have the negative impact of killing any vegetation that was there that might have been able to help hold the bank together. And just see some more examples of that. These flat pieces of concrete that have migrated downstream from where they were installed. And then you're causing other issues, diversions in the stream channel, additional erosion then from that. And just, these same kinds of issues with trees then leaning from the erosion and catching things. So we'll talk about how to address some of these. We did mention the part, in that email about, people mowing next to the stream. I tried to mow it out. One of the things, like, this is a beautiful stretch of stream channel. Look at nice floodplain connection there. Floodplains are really important because it gives us the chance, when we get a storm, that water to spread out. It both stores the flood waters and it produces the energy that flood waters are carrying. So moving water is energy, and energy when it's water is erosion. So it gives it a chance to dissipate that energy. But man, mowing this down to then, I've seen this guy a few times out here doing this. This is close to a site we were doing some monitoring on, several years ago as part of a project or a study, and tried to talk to him, this old German guy, and he was not having it. He's like, we're mowing this, but really we'd want to see, it's still a good floodplain, but like that really makes it a lot more susceptible to erosion, especially if that's not actually, they're not using it for anything. There's not a path there. Really want to see more vegetation there, especially, woody vegetation helps hold those roots help hold the stream banks together, even though they can cause some other problems. We'll talk about how to kind of compromise between having woody vegetation next to the channel and keeping it out of the channel and keeping it from being a nuisance. Just another example of a log jam or debris jam. And sometimes these are get beaver dams and things too that you maybe have to deal with as well. So this one's, I think, much more of a straight up log jam. So We're going to address all these issues and also some of the programmatic aspects of how you want to set up your program. This is all in the manual as well. So, this obviously the webinar is being recorded, but also don't hesitate if you have questions about this afterwards to shoot me an email or anything like that. But so what are some pieces of a successful program? If you say, all right, we want to set up an actual program, what do I need to do if I want to set up a stream maintenance program in my community? So first is regular inspection. And, depending on the size of your community, it's probably not feasible to inspect every mile of stream, bridge, culvert, crossing, everything in your community every year. So, but over a reasonable amount of time. So you might want to set it up into, break it, in this example, break it into quadrants, or what have you, where you're inspecting those on a rotating basis. Just something where you get scheduled and getting out there regularly. This doesn't have to be staffed. There's one community you work with where they have the wastewater plant has interns every summer, and one of the things they have them do is go out and walk the stream channels and note issues, things like that. So it doesn't have to be a full-time person's job, but just you want to be out there taking a look as often as possible. So what do you look for when you're doing an inspection? Well, the kind of things that we note here is the streambank erosion, and then not only is it eroding, but is it threatening any infrastructure? Is it impacting anything downstream? Just all that sediment, is that sediment clogging a road crossing of any kind? Obviously, you're looking for debris jams, dead and severely leaning trees, low-hanging branches. And really, those low-hanging branches, that's only if it's an area like low-hanging branches and you see they're catching something, or like really low-hanging that are obviously going to impede flow or catch debris in a larger storm event. Sediment deposits, and I've mentioned here, especially mid-channel bars. So it's like an island in the middle of the stream channel. That's a really clear sign of that the channel is not stable and is migrating, moving around a lot. And obviously that's pushing flow out from that to the stream banks. Vegetation, especially if it's growing in the stream channel, a lot of times on those mid-channel bars, you'll have that vegetation. That's just another sign. You want vegetation next to the channel, but in the channel, that can be an issue. And then you want a standardized method, rate, severity. And so, we often use what we call the Bank Erosion Hazard Index. That's a little more scientific. It doesn't have to be that bad, but the important thing is that everybody who's doing these inspections is rating things the same way. So you might be going out once or twice a year, just everyone together to say like, hey, well, we're calling this a 3 because it's this high and it's undercut or something. As long as it's standardized and everybody's rating it the same, or maybe it's rated more severe if it is next to infrastructure or things like that. So you just need a standardized way to handle those kind of things.
Jared, we have a question for you.
Yep.
When you do stream inspections, do you access private property or just view stream sections from public infrastructure?
Yeah, so ideally you're accessing private property. Now that, depending on what your agency and your own protocols, that can be definitely something you need to look at. When we've done stream inspections on private property previously, you can send out, first we tried sending out mailers to people who live along the stream to say like, hey, please respond to give us permission, and to get such a low response rate, we actually started doing something where we are going to be walking the stream between these dates. If you do not want us to access your property, let us know. Here's how you respond to let us know. And we'd get a few people, so we'd have to make sure to avoid those properties. As a soil and water conservation district, we are able to access private property as part of doing our work, kind of disposing our duties, however they want to legally say that. We're not allowed to trespass. So if somebody tells us, no, you can't be here, we can't go there. But we definitely, that's a benefit to partnering with your local soil and water conservation district on something like this. But we definitely want to let people know. And if you're doing this as part of your community, that might be something you put out in a community newsletter too, just in case people miss the mailer somehow. But obviously, if we see people when we're out doing this, we'll talk to them. We'll initiate conversation with them as well. So that's how we've handled that for when we've done, because a lot of streams and areas where, for the most part, where you need to see is on private property. So it is a legitimate concern or something you need to work out. All right. So just some examples of, like erosion. I said, obviously it's very small stream channel. I'm there for scale. I'm about 6'3", so you can see the height of this erosion here. And the stream channel, like there in the upper right portion of the picture, you can see kind of the original channel. You can hop across that. So something went and got some severe erosion going on there. Again, the debris blockages, these trees leaning across the stream, kind of this rotation leading to slope failure. The problem with these, it's not just blocking the stream channel, but they're pulling the slope down into it with them. So these are kind of things you'd be looking for if you're doing your stream inspections. You're not just looking at the stream channel, you're also looking at bridges and culverts. This may be something where yes, you want to do it on a regular basis, especially to note sediment and things like that, but might want to do some post-storm inspections as well. If it's something severe like pictured there, somebody's going to let you know about it. Like, it's not going to be a mystery, but there could be different blockages that aren't quite that severe, that aren't as obvious from the road, that could start to cause issues if you're not in there taking a look on a regular basis. So what do you look for on your culvert and bridge inspections? Look for like sediment blockages and filling in the channel. You might note like, hey, is this mostly like, sand here, or are these like large like boulders or cobble sized pieces? Also any deposits if it's immediate downstream of the culverts as well, that are upstream, that could indicate different issues. Debris, woody or otherwise, lawn equipment, patio furniture, that kind of thing you get in there sometimes. Shopping carts, we have a fair number of those in some of our streams around Cleveland. Then you look at, for erosion around headwalls and footers. So when you get some of these blockages, like you start to get eddies downstream or upstream of these crossings, especially with the culverts, and that can get some erosion where it swirls back around and start to get the erosion around headwalls and things like that. And then again, like, how are you going to rate the severity of these? So how, again, you don't have to use the exact things that we recommend. In the manual, it does have like some tables, some forms almost you could use. You're certainly free to use those, but really the most important thing is everybody's doing it the same way, doing these inspections. So are you looking at how much of the cross-sectional area of a bridge or culvert is filled with this sediment? Is it obviously impeding conveyance during storm events or even during low flow situations? As an example, here's a bridge, and obviously it's getting some sediment built up underneath there, and it's even changing how the water flows out. We're looking from upstream to downstream in this picture. So it's leading some erosion downstream just by how this bar basically is forming in the channel. And then here's another example of some smaller culverts. Maybe these are, I think, 36ers, but they're blocked. And again, this is an example of one that might not be obvious from the road, but it's obviously impeding conveyance there. So like I said, the most important thing is need a standardized method to rate severity. So you need regular staff training. And training's not even the right word, but like just consensus, make sure everybody's scoring things and seeing things the same way. The legal issues about inspections on private property, like I said, that's a good one for your law department to see if you can, get away with what we do, where we kind of send the thing and ask them to opt out instead of opt in. Or if you just need a general announcement and what your legal authority is as far as accessing private property. But the regular inspection, it does allow for a holistic or prioritized approach. So once you can rate these and you've inspected these and you have a rating for the severity of the condition, you can prioritize what you want to do, where to do it, but it also gives you, something with a resident calls and it says, I got this problem, I got this is blocked, or I got this erosion. You can say yes, we're aware of that, but it's the severity of your blockage is only a 2 out of 5, and we're dealing with these others that are 4 out of 5 first, or something like that. So at least you have a system. So if why did they get that, or why did my neighbors get the work done and I didn't? Well, maybe they had a more severe situation, and it's based on something, so it can't It's not like, oh, not based on, well, his brother plays basketball with the mayor or something like that. So moving along here, get to the part about, making it stream friendly or watershed friendly, or as I say, at least less unfriendly. Kind of how we see this, after, working in watershed management for a long time, kind of the eternal conflict here is conveyance and drainage versus everything else. The paradigm, or if you want, of municipal engineering, from the really 50s through the 80s and 90s, even into the 90s, is really get water off the landscape as quickly as possible and move it along as quickly as possible so that we don't have it flooding, we don't have it sitting there. That's, great, and we've done a fairly good job of that. The problem is we almost done too good a job of that, so that water gets moved downstream faster and drains through storm drains faster than it would in a natural situation. And so we end up with a lot of erosion. So wherever this trapezoidal channel, concrete lined trapezoidal channel, wherever it flows out in something, it's not that, I almost guarantee there's going to be erosion and other issues there because that water is being conveyed so quickly. The other problem is, this would in nature be a nice, happy headwater stream with amphibians and salamanders and macroinvertebrates, and now this is anything but. Like, there's not going to be really anything living in there. Maybe if you get some sediment deposited in these, you get some leeches or something, that's going to be about it. So really, it's not a healthy stream environment. And this is obviously in a kind of extreme situation, but it's not uncommon to see things like this. And finally, with the concrete line channels like this, especially, there's no vegetation or anything next to it, no trees, is you're heating that water up pretty highly. So that's warm or hot water being discharged into the more naturalized stream system when it gets there. And warm water, of course, holds less oxygen and all sorts of things there. So there's a lot of issues with this kind of engineering that makes it make it great for getting water off the landscape, but not great for stream health. So we're always fighting this. And when we get into stream maintenance too, these issues of, well, we need to maintain the conveyance at all costs. It's not always the best option necessarily. We can argue and kind of demonstrate here how we can have both maintain stream channels that aren't causing issues that also are healthy stream channels for wildlife and everything else that wants to use that stream. So some examples of this, as watershed stewards, we want forested and vegetated, riparian or streamside corridors. We also want and understand the importance of large woody debris in the channel. It gives diversity, great habitat, and in a lot of situations it can add stability to the stream channel. We want floodplain access, like that's one of, at least in Northeast Ohio here, we have a lot of channel incision, down cutting of stream channels, and really the best thing we can do, what we really want, is reconnect them to our floodplain so that when it rains, we get a storm, that stream water can, instead of concentrating all the energy and flow in the stream channel, get it out on the floodplain where, as I said before, you can dissipate that energy and store those flood waters. And we also understand, the main functions of the river in the landscape are transport water, transport sediment, and transport wood downstream, and also provide habitat and nutrient cycling. I'll add that as well. However, as municipal officials and owners of infrastructure, these often sound horrible. Like, what? We want woody debris in the stream channel? Are you kidding me? So we'll talk about just some things we can do here to kind of meet both the conveyance goal and the healthy stream channel issues. So, mains on which we can all agree. So sediment and woody debris at culverts and bridges, that needs to be removed. Like, it's obviously an issue. Like, that's not going to do anything for anybody as far as conveyance. It can actually cause issues with fish passage and other aquatic animals being able to move upstream. But there are ways to do this. For some of these culverts, like, we really do like to have not just and we'll talk about a little bit more of this later, but really like these embedded culverts where you have a riffle almost running through this culvert that provides habitat and places for critters to hide and move through the system. But definitely, if you get in blockages, but it's got to be designed for that. If this culvert was designed that, hey, this whole thing needs to be conveying water or else it's going to back up, then you really don't have room for this. So you got to design to be able to have these kind of things. And I definitely, when you're removing debris from channels, and we'll talk a little bit about some of these issues, but definitely there's some really good guidance from the American Fisheries Society and also the Natural Resources Conservation Service out there on how to do those. And maybe I'll put those, send it out to everybody too with in a follow-up email. Then related to riparian corridors and vegetation management, you know, you do want to remove fallen or severely leaning trees if they are causing an issue or potential cause an issue. A lot of this has to do with location in the stream channel too. If this is just out in the woods, it's just out in the woods, not going to impact anything. You don't really have to, there's no reason to necessarily to do anything. But if it is going to potentially impact infrastructure or you are close to road crossing where it could cause issues, you do want to kind of maybe remove severely leaning trees or fallen trees, but definitely want to leave the stumps intact because those root wads help provide stability for that stream bank and provide some of that holds the soil together even then once the tree is dead and the rest of it's been removed. But you pull that, get that weight of the trunk falling over, leaning trunk out of there that's going to be pulling the slope down with it. You can trim low hanging. This is an extreme situations. Trim those low hanging dead branches. Like I said, if this is where you have known conveyance issues and it is impacting infrastructure of some kind in a natural setting, you would never go out and do that necessarily. And then if only bridges or large block culverts are downstream, you can cut your logs small so they could pass through that and leave them in the flood channel or floodplain. Like, I can't emphasize enough how good that woody debris is for the stream health. But if you really are having trouble with that clogging culverts or something like that, you would want to then take that out of the floodplain if you removed it. And then as much as possible, always maintain that vegetative cover on stream banks and in the riparian zone. It just provides so much stability and helps reduce low velocities, you know, in the floodplain and in the channel. So it's really like one of the most important things we can do for stability is maintaining that vegetative cover. So as an example, yeah.
We have another question. You don't mind? Yeah. Confused about the culvert with gravel in it. Is it good or bad? You mentioned habitat.
So it's good if it's designed to be that way. It's bad. I say most of them are not designed that way, and we'll go into a little bit a slide coming up here that shows some of the design, how you would do that. But it's only good if it's designed to be that way. If it's not designed for that, then it's probably taking up too much of that volume to pass the design flow. So I got another slide coming up, kind of addresses that a little bit more too. So maybe after that one, if there's still a question, we can talk about that some more. So some examples here with the leaning trees. I've seen this picture a few times. So like if this was causing a problem, causing jams or water to back up and cause flooding of infrastructure, things like that. This is where you would come in and potentially, make these cuts, leaving the root wad on these, but remove the rest of that out of there. So some common stream problems and solutions. So we're going to talk about stream bank, some different ways you can address stream bank erosion, debris and log jams, and we'll discuss flooding. That's a whole larger issue if it's not caused by a localized blockage or something like that. But so these are just different problems we see a lot. Stream bank erosion, as I mentioned, is like the #1 thing we get called out for technical assistance by landowners, communities, everybody. So just see some severe examples of that, even just small. The one in the upper right, picture in the upper right hand corner, it's just somebody's yard, a little stream, but obviously it's just mowed up the edge of that and it's cutting down, eroding. And once you start to erode down, that's more and more of that stream flow that during high storm events is being conveyed in that stream channel, and that's more energy in the channel itself. And so more energy equals more erosion. Just see some of the examples of that. So, people a lot of times say like, oh, I got this running stream bank, I should throw some concrete slabs on top of it. Oh, my brother-in-law has a construction company, get me all these slabs. Well, that's not what we want to do. So as I mentioned, the vegetation one of the benefits is it reduces the velocities, that near bank velocity that you would get on the stream channel. So it helps reduce that erosion in addition to holding that in. Also, these flat pieces in a big flow, these are just going to mobilize easy. These flat ones especially, just the way that the water will pick those up. And we find those oftentimes just scattered downstream, causing additional issues because it's kicking water in different directions and everything then too. Also, we like to say, this just moves the problem downstream, because it maybe give you a temporary fix at this location, but you're just bouncing that flow and redirecting that velocity downstream. And so now your neighbor is going to have an erosion problem. So as I mentioned, some solutions for streambank erosion, leave a vegetated buffer, streamside forest, whatever you want to call it. Riparian buffer kind of in some places has a bad name, but streamside forest, something you can go with. You get that tree canopy, the understory, the roots holding everything together. Has a lot of benefits for both wildlife and stream health and stability. Now, you might not be starting from that, so you might need to go back in and reestablish some of those. But in this example, this is the area you would vegetate. A lot of times, if you're dealing with people on private property, especially if they have a smaller yard, they might not want to give up that much of their yard to trees or something like that. But realistically, the slope, at least, you'd want to vegetate this. And whoever's mowing that, you probably don't want to mow that anyway. So you want to revegetate that area with trees. We really like the woody vegetation where we can, because those roots are really good for holding in the stream banks. But sometimes that's not always appropriate. You can have more just vegetated, a meadow or prairie, something like that. Those native plants, those native wildflowers are still going to have deep, dense root systems that help you out better than just mowed lawn would. Some other solutions for erosion are, we're going to talk about some bioengineering solutions. So live stakes, these are cuttings of things like sycamores, some of the different dogwoods, willows. It's a whole range of species that will root from these cuttings, basically. So as long as they are installed so that the base, once they're installed, is kind of in the water table, so they're accessing the water, so right next to the stream channel, they will sprout from that and grow and root and provide stability. And again, it's the roots providing stability, but it's also the branches and eventually the leaves helping reduce the velocity right next to the stream bank. So you're reducing the erosion that way as well. Live fascines is another thing we use. These are bundles. You can see it there in the picture, bundles of basically these same materials you'd use for the live stakes, the same species, planted, installed along the stream channel where they'll root together like that. And often you use the live stakes as stakes to install them in place and hold them in place. You just install these either along the stream, like right above the stream bed there, especially on steeper kind of situations. Or combination of live stakes and fascines like we have here, fascines along the water, live stakes holding some matting above it. You can kind of see how you would install those. It's really, and they're cheap too. I mean, the live stakes are a couple bucks a piece. So you can afford to try and throw a bunch of them in there and see how that works for you. Now, it's not instantaneous. So if, it's, unlike if you're putting concrete slabs, you feel like, okay, maybe that's an instantaneous, I'm going to get some benefit. These, you got to kind of wait for them to root. So it might take a season or two to get them installed. And these, realistically, we're installing between about October and March while they're dormant is when you want to be installing those. And then other combination of this, these brush mattresses, where basically you're laying these stakes, these same materials down along the stream bank, or and then tying them down with stakes and twine. You're in this picture, you'd cover that with soil. You want soil on top of those, and you got to just make sure that that's staying wet. So the bottoms of these, they're oriented so that the base of these branches are down in the water or close to the water line, so they're able to access that water so they can grow. And again, these will root then into the soil there all along the branches to provide kind of good coverage there. The other benefit to doing this is you get some coverage immediately from the branches laying along the stream bank. Now, a lot of times you don't have, you end up with vertical stream banks. So if you have the space to do it and the equipment to do it and things like that, ultimately grading that out to make a more gradual slope is really the best solution. Now, it's very understood that you don't always have the opportunity to do that. Both from an equipment standpoint and access standpoint, cost standpoint, things like that. But it is one thing you can do, especially in those severe steep stream banks. And finally, if you're doing grading.
We have a few more questions.
Yeah.
Okay, is permitting or coordination from the Army Corps or Ohio EPA needed to perform these common stream solutions?
Yeah, and I'll talk, actually I got a slide about that later, so I'll touch on that later in the presentation.
Okay. We have one more question. How do you prevent rush mattresses from being swept away in large rain events?
So, I mean, it's always a risk. So those are anchored. So they are use posts and like twine or some kind of rope or similar to anchor those down and tie them down. It's no guarantee. Like if you get one of those huge rain events afterwards. So they are being kind of anchored in place. They're not just being kind of laid up on the stream bank. All right, and yeah, we'll talk about permitting here closer to the end of the presentation. So stream bank and grading and bank full bench. If you're going to be grading, sometimes it's great to make, if you have the space, a kind of little floodplain. If you're familiar with some ditch maintenance and design in the more agricultural areas of the state, that's kind of similar to the same concept as a two-stage ditch, where you basically, that water can get up there and dissipate energy and flow. And so usually under most flow conditions, it's just in the narrower channel, but it gives you a floodplain, basically a small floodplain to work with during larger storms. Now, dealing with losses of conveyance, debris and log jams, again, it's only an issue if it's causing a problem. If you're out in the middle of the woods and there's a log jam and it's blocking things up, but it's not causing any other issues, there's no reason to take that out. It's really only an issue if it is, flooding a road, causing erosion next to it that's eroding towards some kind of infrastructure, potentially causing or upstream flooding or property damage. And causes can be sediment buildup at bridges and culverts. Again, log and debris jams are kind of ones we get kind of asked about. We get this more than the sediment issue. All the time you get people want to, just go in there and dredge the channel. Let's go in there and dredge the channel. It's like, think back to that first picture, kind of inspired all this. That's like almost never the answer. It really causes a lot of problems and instabilities there because you're tearing up roots. You're tearing up a natural, oftentimes stable system, what's left of a stable system to do that. But there is targeted removal where you do maybe need to take out a stream channel. So again, not take out a stream channel, take out a debris jam or a log jam. So if you're inspecting these, things you would want to note too are like, does this span the entire width of the stream channel, significantly impeding flow? And again, they're only problems if you're threatening infrastructure. Otherwise, they can be extremely beneficial. That woody debris is very important in the stream system for both chemical cycling. It provides a lot of carbon for the system. Also stability. If it's getting backed up, and here I'll show it in this next picture you'll see. This is a picture of a log jam. So the way that the stream's flowing here, it's flowing from the bottom left of the image up through the middle to the top right is the direction of flow. So you can see it's pretty well jammed up there. You even got sediment built up behind it. What you also notice here is, and I wish, this is from several years ago, but I wish that I had kind of stepped back a little bit more, but you can kind of see it here. Upstream of this debris jam, so in the bottom left corner, it has really good access to that wonderful floodplain, that forested floodplain over on the left there. It's not incised there because the channel is the log jam is helping to kind of arrest this down cutting of the channel and actually catch sediment and raise the level of the stream bed to match the floodplain better. So it's actually providing quite a bit of services there related to the floodplain, especially you see the channel erosion and those bare banks on the left side downstream of that. However, you know, so if this is just in the woods, that'd be a great thing. However, what you can't see here is off to the right of this picture, about probably 15 feet to the right of this, and this channel starting to cut around to the right of this, about 15 feet to the right of this is a parking lot for a condominium complex. So when we went out and took a look at this one, we did recommend removing it because it was threatening the infrastructure there. So just some tips for when you're removing debris and log jams. The biggest thing for all this is like access from outside the stream channel. So use a long reach excavator. You do not want to track equipment into the stream channel if you don't have to. Sometimes it's unavoidable, but that's the biggest thing. I think the number one tip is access from outside the stream channel and pull the stuff out that way. You obviously want to dispose away, especially with sediment and stuff, you want to dispose away from the stream. You don't want to basically next rain bring back in the stream channel. Really want to only, unless it's one of those severely leaning trees we mentioned before, you only want to remove the dead vegetation, loose debris, leave the stumps and roots as much as possible. And you don't want to do this during a big storm event unless it's an emergency situation. You really don't want to. You want to do this during a low flow situation, and if possible, you're avoiding spawning season on these, and that just would depend locally on the species you might have there. That's something you might check with the state with. You want to directly take sediment directly to the dump on an access road. Like basically, we're trying to reduce the amount of sediment than just dropping the floodplain if you're taking out of here. It's really a bigger project, use erosion control practices. And the area where you're doing a lot of the work, the transfer of materials, you want to have that away from the stream as much as possible. So, just see at some of the stream crossing here, some examples of, and some of these are even just footpaths in people's yard. And that's something that, if I was coming out, I'd be like, well, that's your responsibility to take care of. But just an example of how, that could be in a park or something though too. Example of how this debris can really hang up on these crossings. Just another thing to consider at stream crossings is erosion. So this is obviously, you can see in the middle of the picture, there's a culvert. The bottom of the stream, when they installed this, and this is just somebody's driveway culvert, so it's a fairly small channel, but when they installed this culvert under their driveway, the bottom of the stream channel matched the bottom kind of the culvert area there is maybe a foot drop down to it. And now you see just the amount of erosion. There's been some upstream development that maybe isn't being properly controlled by stormwater control measures. But I think also the just looking at it, the culvert is probably undersized to start with there. It's just kind of getting a lot of pressure coming out of that culvert when you get the rain events. This is that same stream channel looking downstream. Just as see, it's not a large stream, but just the massive amounts of erosion you're getting downstream of that. This is that channel upstream. So this is flowing into that. So you can see it's pretty small channel most of the time, pretty small stream, but due to the undersized nature of the culvert, and this culvert, I don't know, you don't know why people do things sometimes, but this culvert upstream coming under the road here, it's about twice the size of the culvert going under the driveway. So that's obviously part of the problem as well. Now when we get to flooding, I mean, this can be an issue you have at stream crossings if you get backups. Maybe you have a backup stream downstream that might be cause flooding, especially in you got a road that a bridge that's lower or a ford or something like that. So that's another issue at stream crossings. Now, if it's a regional flooding kind of issue, just clean out all your drains, your culverts and things aren't necessarily going to solve that. if there are other issues at play, but sometimes these can be caused by backups. So just something to keep in mind when considering stream crossings. So some of the planning and design recommendations for that, obviously avoid or minimize crossings. The less crossings you have, the less chances you have for issues to pop up. This obviously goes way back in the planning stage when you're designing maybe subdivisions or things like that. Bridges preferred over culverts in most situations. There's more leeway as far as passing storm flows. A little more just better at passing that and also not disrupting the stream bed and the sediment and the habitat there. And bridge and culvert width, greater than at the minimum, like 1 1/4 times the bank full width. See, this is not a good example of that necessarily, because you can even see this is like under low flow conditions that water, like it's narrower than the stream channel, and that's always a good way to say, like, you can see that automatically and say like there will be problems either upstream of this or downstream of this because of that. So we talked about, there's some culverts that are designed to have that sediment. There's a question about that earlier. There are some ways to do that. But again, it has to be designed that way. You have to be designed to be passing that flow through there, including that the sediment that's in there. So that volume has to be accounted for. So, bottomless culverts would be preferred. If not bottomless, embed the bottom 20–40%, design for it, and match the natural channel slope. We get a lot of these too, where it's just a flat, almost or near flat culvert going across that doesn't match the slope of the channel. So just some examples of that there. And there are lots of good guidelines out there for ways to do this. If you look it up, you have a source here, culvert criteria for fish passage. Just kind of thinking about some of these issues. And this is another one that's not a good idea. You can just see, like, in this eroding channel, like these culverts are just, you don't have to be an engineer to know that this is just not going to work out very well. Obviously, you're getting enough flow to work back and forth and erode that whole stretch there. And then also, it's hard to see in this picture, but they're not even lined up like straight on with the channel either. So it's kicking the flow over to the side. So this is a example of what not to do. And you can see, the channel erosion was happening before they put this in, but it's not, it's going to still have some problems. I'll have to go back and take a picture of that now and see how it looks.
Yeah, we have another question for you.
Yeah.
If a repair is found needed on private property, who performs the work? For example, a retaining wall failing that is protecting a private driveway.
So, that really depends on the program in your community. So some communities might say, hey, we will do that work. It is not, it's the way the law, as it were, and I'm not a lawyer before I go on to say this, but generally the person who owns the property is required to do, is not required, but they're responsible for any maintenance they want to see performed on it. So that is like the baseline with Ohio water law. Pending other agreements or things like that. But that is the baseline situation. Unless, some communities have said, like, okay, we want to start a program, this is definitely an issue, or, if it's threatening public infrastructure or even private infrastructure, maybe there's ways they can help. And that can range from, just guidance and technical assistance to providing something, but the baseline is the property owner is responsible for any maintenance. Now, it doesn't mean they have to do maintenance on it. If it's just threatening their driveway and they want to let it go, they can let it go. But if they want something done, they'd be responsible for that. All right, so I told you we get to the kind of the permit situations for this. For a lot of this, so I think the question came up specifically about, some of the bioengineering and things like that. It really depends on how much you're doing and how much filling you're doing. So in the manual, we laid out all these different, laid out the different nationwide permits and things that are necessary. And basically, so just to orient you with the kind of columns in this, so, the activity which nationwide permit that is, and then if you are required to file something with Army Corps before you do any work or not. So that's called a pre-construction notification. So some things require it, some things don't. And even between this nationwide print number 3, it just depends on what your kind of repair you're doing. You know, if you're placing riprap or things like that. Ones that we often see for this kind of work are bank stabilization. So it really depends. So if you're must submit something to them ahead of time, basically get a permit, is how people say. If you're doing more than 500 total feet, or if you're placing more than 1 cubic yard of material per foot along the bank, so just below the ordinary high water mark. So that those are 2 conditions under which you would need for, like, say, a bank stabilization project. You would need to do that. But for some of the basic things, for minor discharge, this is removing sediment in a small channel. Say you got some blockages in channel and it's potentially causing issues, you want to remove it. If you're excavating more than 10 cubic yards of material below the ordinary high water mark, then you would need to do a permit ahead of time. So those kind of things. So it's a lot of planning and knowing what you're getting into. But for instance, this next one, like removing limbs, waste, and debris from stream channels, as long as it's dead, you don't need anything. But the condition on that is you need to lift it out without entering the stream channel. So I would say anytime you're getting equipment like tracks or wheels into the stream channel, then you need to call Army Corps to verify any of this. And so these in the manual are based on the nationwide permits, an earlier version. In the handout section, I have a summary table that's got the more recent, up-to-date, current nationwide permits information than what'll be in the manual. And that most of I went through them. There's not any really changes for the kind of things we're talking about for the maintenance program that I noticed, but I just want to make sure you had the most up-to-date versions of that. So that other handout is a summary table of all nationwide permits and when you would need to do the pre-construction notification, which is kind of what we call, when people say get a permit, what they mean. And with that, we'll wrap it up. If there are any questions on that, I guess we take it now. Also, you can always email me with any specific questions you might have about specific situations. Again, or also please email me if you want hard copies of the Watershed-Friendly Stream Maintenance Manual for communities. Like I said, I got a lot of copies of that. I'd be happy to send out 1 or 100 to you. So.
All right, we do have one more question. Does OEPA require permitting for dredging reshaping?
Yeah, and again, it depends on those situations. So how much you're doing, but anytime you're moving the stream channel, I definitely, and a lot of those, there's a lot of nuances. I would always, when in doubt, ask before you do it. So dredging, there are a lot of different circumstances. Look through the table there. It depends. There are multiple circumstances under which you do and under which you don't. So if you're reshaping though, you absolutely, so if you're reshaping a stream channel, like changing the course, you absolutely do.
Okay. And just so everyone is aware, we did have a couple questions. This presentation will be uploaded to crwp.org. I'll send out an email once we get that uploaded, so in case anyone wants to view it again or share it with anyone. If anyone has any more questions, now would be a great time to ask. Other than that, it looks like we're about all set.
Great. Well, thank you everybody for taking some time out of the morning to learn about how we can better maintain our stream channels to both maintain conveyance and healthy watersheds.